Hello, welcome to my class. Today I will teach you about the entity relationship modeling. So this table of contents I will teach you from what is a relational database, entity relational database, how to build the design, entities and attribute, relationship and cardinality, what is a primary key, foreign key, modeling, data types, relationship modeling, table relationship, strong entity versus weak entity, recursive relationship, ER diagram, database integrity, and summary. So we start our introduction. So what is the relational database? Basically, it's a set of formally described table from which data can be accessed or resembled in many different ways without having to organize the database table. For example, data from JPN has been reassembled with data at JPK to become a relational database that has been used by the police officer to identify the criminal record of car driver. So this is example of the entity relational database. So basically it's a structured diagram for use of database design. So as we know, every building has their own drawing document or building plan. As an architect will design building plan for specific building. Same with database. Every database has their own document. One of the document is called as ERD. ERD is a structured diagram for use of database. Okay, there are a few steps how to build entity relationship design. First is identify the entity types. Second, identify and associate attribute with the entity types. Third, identify the relationship types. Fourth, determine cardinality and participation constraints. 5, determine primary and foreign keys. 6, validate the model. So this as the example of the entities and attribute. So customer order we can consider as an entity. The specific types, first name, last name, address, we can consider as attributes. So this is the technique how to convert the table to be a ERD. So most of the time you find the step of identifying entities and the attributes is easy. This is an example of how to convert table to be ERD. Relationship and cardinality. Since each order needs a customer, the UML diagram shows a link between the symbols for the relations. Sometimes the nature of the relationship is marked with the verb. Here, the relationship is simply has. In practice, you will find many diagrams that don't include this. The next step is determining the cardinality of or multiplicity of the relationship. The most common relationship is one to many. In this case, one customer will have 0 or many orders. But an order will have precisely one customer. The UML notation shows the cardinality as 1. 1 on the side of the customer and the 0 star on the side of the order. The star of asterisk means an unlimited number. There are also one-to-one relationship. For example, if our staff are issued with company's cars, each car will have one user. Many-to-many relationships do not work in the relational model. If we have teams, we have to solve them by using another table in between the table that have the many-to-many relationship. The participation constraint checks whether entity must have a link to an existing entity. In the UML notation, this information is included in the cardinality. If there is a 0, participation is not mandatory, otherwise it is. So this is we call as a relationship. Has relationship. The number we can consider as a cardinality. Okay, primary key. Okay, basically primary key is like an ID. Primary key are attributes that uniquely define the entity. Among on all the attributes, we have to find one that will different in each entity. Clearly, names are not very good at distinguishing between customers. Many people have the same name, but for number, it's a unique. For in this case, we use a 1234 1111 as a primary key. Okay, foreign key. Foreign key basically is like a ID that we use in other table. For example, this is the primary key of the customer, and we use in the table of order as a foreign key. Relationship modeling. In most enterprise, one order comprise a number of line items. If the customer is a corporate, one order is likely to be for many products, and the order quantity for each product will be more than one. So we have to store the product and the quantity for each line item. The line item in the order is product specific. Within the same order, we don't mention the same product twice, but across all orders, the same product will be mentioned many times. When we look at the table, the obvious flaw is the order number, customer ID, and that repeat as many times as we have line items for a particular order. In relational design, we really dislike repeat entries in row. That's why we usually make two tables for order and order line items. Okay, so this we can consider as a good design. Now that we have separated the entity into different, the customer ID and that field no longer repeated. Data field no longer repeated, but the order number still does. It is okay. Order number is a foreign key to the order table. And because there is a one-to-many relationship between order and order line, repeating foreign key are unavoidable. But we have avoided repeating customer ID and that, which are dependent on the primary key order number. There is an additional column line number in the order line table. This is necessary if we care about the sequence in which the order lines appear on the order. For example, when we print the order or show it on the screen, the BMS gives no guarantee in which order tuples are sent to the user. The sequence may differ every time. But more importantly, we need a primary key for order line table. Order number won't work by itself, but because we know that there will mostly be several order items in each other order. What option do we have? We are looking for field that is unique in combination with the order number. Could it be product? Not a bad idea, because in most companies, each product will appear in one line on an order. So product order number is combination make a good composite primary key. Will quantity qualify as second part of primary key? Clearly not, because we can already see in the table that order 1111 has a quantity of 5 for all its product. So this is not going to lead to a unique identifier. Candidate keys are valid option for primary keys. In the order line table, we can see we have two candidate keys, order number and line order, or order number and product. The case against product is that is a text field. Searching by search in a field is a time consuming. So the best candidate here is order number and line number. Data types. So this is an example of the data type. Currently we have here integer, decimal, dat, string, LOB, and binary. Char and varchar. Char and varchar is considered as a data type also, but the difference between char and varchar is like this. If you want to store, we want to save the storage, we should prefer varchar. This is a trick. Okay, why I should avoid text attribute as a primary key? Actually, we can use the text attribute as a primary key, but it's not advisable. Why? Because of the it will have a problem when doing searching. The searching name will be same in the database. But how about if you use number as a primary key? When you compare number, the entire number is compared at the same time. Number encoded as a single binary value. To compare them, the process subtract one number from the other. If the result is 0, we have a match. This is why number should be preferred to text field when looking for a primary key. Having said that, we often find string coded ID field. This is because people like to categorize. So you can find a few letters for the category and then a number. These fields are not ideal for primary key, but okay, as long as you don't use very long text field, say over 10 characters long, then it should be okay. So this is the example how we design a good relationship modeling. Currently, there are 6 different of the table relationship. The first one, one-to-one. Second, one-to-many. Third, many-to-one. Fourth, many-to-many. Fifth, zero-to-many. And the last one, many-to-zero. Thinking about the scenario of the education, student may take several subject times, and subject have many student enrollment at any given time. This leaves us with many-to-many scenario. Many-to-many relationship just don't work in relational model. In effect, many-to-many means circular relationship. Each table have foreign key that links to another table. Because for each row, there are links to many rows in the other table. The row has to repeat accommodate at the link. At the same time, the other table we are looking the same row just to accommodate different foreign keys. Copying with so many combinations is not practical. Actually, it is not even logical. We have subject as title and convener, but the subject entity shouldn't be have grade for each student. So the simple story is many-to-many relationship just don't work in the relational world. What do we have to do it? We create another table in between. So one-to-one, what I can say is, for example, a student taking one courses. That's what we consider as a relationship one-to-one. For one-to-many, a student one taking many units. So this is the example of the second one. Many-to-one. A many units is teach by a one lecturer. Same goes with the many-to-many, zero-to-many. This is a possible condition of the table relationship. So this is the example of the table relationship. I designed this by using draw.io. So we have here one-to-one, one-to-many, one-to-many, one-to-many. Okay, let me describe. Okay, student have one Canvas account. One student should have one Canvas account. Student taking course. One student should taking one course. And one student and many students should taking one course. So this one to many, one to many. One course consists of many units, and one unit consists of many courses. So we go to the next slide. Strong entity and weak entity. As we mentioned before, the entity is like this. We can consider as a entity is a table. Strong entity, weak entity. The difference with the strong and entity is strong entity and weak entity set always have parent-child relationship. Means Weak entity will have foreign key imported primary key strong entity. Example, one student have one Canvas account. Those Canvas account will have FK imported from PK student. So then another example of the weak entity. So this is the example. Creating a table that connect the table student and subject is called expanding the relationship between student and subject. You can see immediately that this makes sense. Now we can have column for the semester. A student has taken a subject and the grade the student has achieved. All the entity we have looked at so far were strong entities. Strong entities have their own ID type field as primary key and usually describe something very tangible in the real world. The way you recognize weak entity is that their primary key are all made up of foreign key. In fact, the entire table often contains more foreign key than other table. This is an important concept to remember because IT professionals often refer to weak entity when they talk about database design. Okay, recursive relationship. So basically, recursive is all about table that have foreign key that imported from primary key in the same table. In this case, we can see here, this is the primary key. This is a foreign key. Actually, this foreign key 123 is imported from same table. Another one is imported from here. If we got this kind of situation, we can consider it as a recursive relationship. This is an example of the ER diagram. You see here, this is a student. This one environment, subject. We have a 3 different table here. Student consists of student ID and name. Enrollment consists of student ID, subject ID, SAM, and grade. Subject consists of title, subject ID. What we have to do is just convert to here first. And then make a relationship between it. This meaning one student taking many enrollments. One enrollment may be not taken by student. Zero enrollment is takes one subject. No. One subject may be taken by zero enrollment. One enrollment needs many subjects in it. So we go to database integrity. Database integrity means database devoid of inconsistency. Having good data schema mean good structure with properly designed relationship and relationship between them. Reduce redundancy and therefore decrease chances of inconsistency. Primary key and foreign key are tools that help enforce good table and relationship structure. This is a parallel relationship. This one is a child relation. So finally, as summary, here are the most important points discussed in this model. You may want to stop the recording to have read them through. When you are ready, start the quiz about this model. So this is a several example. Each applicant can submit one or more application. Each application is submitted by one applicant. Each school can be associated with one or more application. Each application is associated with the only one school. One application must include 2 or more recommendations. Each recommendation is included with only one application. Each bowling center can be associated with one or more application. Each application is associated with only one bowling center. So this is example of ERD for the situation here given. Okay, we go to another example. This is another example also. Okay, in order to design DRD, I advise you to use a draw.io. In order to use the draw.io, you should have, I think you should have account on Google Drive in order to store the file. So this is the link how to use the draw.io. Okay, tutorial. The example of tutorial. If by given this kind of the situation, this is the read list of James Reed 50 of Grey by E.L. James in March 2016. Did not like it very much. Then the grass is singing by Doris Lessing in April 2016, and it's quite a bit. Okay, in this tutorial, the first thing is you need to highlight which one is important. In this case, I highlight this one. Why? Because I want to know which one is the suitable attribute that I should put in the table. I mean the entity. So the highlight red is considered the unsuitable attribute. I highlight the 50 shade of grey, E.L. James in March 2016. 50 shade of grey we can consider as a book title. E.L. James we can consider as an author. March 2016 we consider as a month or year read, consider time lah. And then this one I enjoy, it's quite a bit, it's considered as like a comment something. So this is the answer. I design a box and put the book title, author, month and year, reads. This is the attribute that already designed based on the situation that I explained before. Okay, this is the second tutorial, second example that I want to show you. First of all, you need to understand all the text here and then highlight the important ones. Here I have like subject, code, title, description. And after that, each semester, you see here, a subject assigned as one lecturer. Each lecturer has a lecture ID and name. A lecturer may lecture in more than one subject in a single semester. The college has many students. Each student has an ID and name. Each student may enroll one or more subject offering. During a semester, a student may post comment in an online discussion board. The college is required to track each comment and the date of time it was made. So this is the answer. One subject needs by many. M is many offering. One subject only should have a many enrollment. One student can go many enrollment. One enrollment can have one result. One enrollment can have a one online discussion board. One lecturer will teach many subjects. Actually, this kind of the design is based on the how you understand the situation that mentioned before. So that's mean the design that produced by the developer usually is not same. It really depends on the creativity, how they understand the situation that have been given by the manager. Okay, so I think that's all. So if you have any problem after this, you can ask me directly to the online Canvas discussion, or maybe after this we can chat, communicate by using Microsoft Teams and the team viewer if you want to do like a lab or something. So I think that's all. Okay, thank you.